Hello, innovators. Welcome back to the Robot Series where we learn, build and innovate using technology and creativity. Today we are going back to the basics, exploring the 8 most important electronic components that every beginner should know. Let's get started. A 1-lead light emitting diode. The lead or light emitting diode is one of the simplest, yet most essential components in electronics. It emits light when current flows through it, but only in one direction, from the anode positive leg to the cathode negative leg. Inside the lead is a special semiconductor that releases energy as light when electrons and holes recombine. LEDs are super efficient, consume very little power, and last for thousands of hours. You'll find them everywhere in indicators displays, headlights, and of course in robots. Always remember, use a resistor to protect your lead from burning out. A 2 resistor. Next we have the resistor, the current controller of every circuit. A resistor limits or reduces the flow of electrical current to protect components from damage. Its resistance is measured in ohms, ohm symbol, and it's determined by the resistor's material and dimensions. Each resistor has colored bands that represent its resistance value. For example, a 220 ohms resistor is commonly used with LEDs to prevent them from drawing too much current. Resistors are essential for voltage division, timing, and signal control, making them one of the most fundamental building blocks in electronics. 3 push-button switch. The push-button or momentary switch is a simple device that allows you to control when electricity flows. When pressed, it closes the circuit and allows current to pass through. When released, the circuit opens again. It's used to send digital signals high when pressed, low when released to microcontrollers like Arduino. Technically, most push buttons are single-pole, single-throw SPST switches, meaning one input and one output connection. You'll find them in calculators, doorbells, and control panels. Push buttons bring interaction to your project, giving your robot the ability to listen to you through touch. For capacitor, now let's talk about the capacitor. The temporary energy storehouse. A capacitor stores and releases electrical energy quickly, like a mini rechargeable battery. It consists of 2 conductive plates separated by an insulating material called a dielectric. The amount it can store is measured in farads F, but in small circuits we use microfarads F or picofarads PF. Capacitors are used to smooth voltage fluctuations, filter noise, and create time delays in power supplies. They help keep voltage steady when current demand changes suddenly. Some are polarized like electrolytic capacitors, which must be connected correctly, positive to positive, negative to negative. A 5 buzzer. The buzzer is the sound maker of the electronics world. It converts electrical energy into sound, alerting, signaling, or giving feedback in your projects. There are 2 main types: active and passive. An active buzzer produces sound when power is applied. No code or signal needed. A passive buzzer, however, requires an external signal, for example from an Arduino, to create tones or melodies. Buzzers use the piezoelectric effect, where a special material vibrates when voltage is applied, generating sound waves. They're commonly used in alarms, timers, and robotic alert systems. A 6 breadboard. The breadboard is your electronics playground. It lets you build, test, and modify circuits without soldering. Inside the breadboard are metal strips that connect the holes in each row or column. The middle section is for components, while the side rails are for power, positive, and ground. This makes it super easy to connect and experiment with different parts using jumper wires. Every engineer, maker, and student starts here. It's where ideas come to life before they become permanent circuits. S7 jumper wires. Next up, jumper wires. These are the colorful connections that carry current and signals across your breadboard. They come in 3 types: male to male, male to female, and female to female. Each type helps you connect different components, sensors, and modules easily. The insulation prevents short circuits, and color coding helps identify power, ground, and signal lines, usually red for positive, black for ground, and other colors for signals. Think of jumper wires as the veins and arteries of your circuit, delivering power and information where it's needed. 8 battery. And finally, the battery. It's the power source that brings all your components to life. A battery stores chemical energy and converts it into electrical energy. When connected to a circuit, it has two terminals, positive plus symbol and negative. The voltage of a battery tells you how much electrical potential it can provide. For example, a single AA battery provides 1.5 volts, while a 9V battery is commonly used in many beginner circuits. Batteries can be single-use or rechargeable, like lithium-ion or lead-acid types. When connecting, always match your battery voltage to your circuit's requirement. Too high can burn components, too low won't power them properly. In short, no battery, no life for your project. That's our introduction to the 8 basic electronic components, the foundation of every great robotics and STEM project. In our next episode, we'll start building real circuits using these components and learn how to make them work together. If you enjoyed this, don't forget to like, subscribe, and share the Robot series. Let's keep learning, building, and innovating together. Earn, build, innovate.